on an annual cycle. So what causes winter as a season versus summer and others. Why we have seasons has to do with which way the Earth's hemispheres are pointed. It has nothing to do with Earth changing its tilt, which many people have as a misconception. Regardless of what time of year we are, oopsie, how do I get out of that? Oh, good. There we go. So regardless of what time of year we're talking, the Earth's orbit is always at 23.5 degrees. It stays that way year round. Now it does change on geologic timescales, as we'll see in a second, but that's not what causes the seasons. What causes the seasons is, are you tilted towards the sun? In which case the sun is going to hit you more directly and cause summer in the northern hemisphere at June. Notice the southern hemisphere at the same time period is tilted away from the sun. So it's getting less direct sun, not warming as much. It'll have shorter days. So they're going to be in winter when the northern hemisphere is in summer. Shift it to the other side of the year. Now look at the situation. Northern hemisphere is tilted away from the sun, still at 23.5 degrees though, while the southern hemisphere is tilted toward the sun. So now they have more direct sunlight. Southern hemisphere is in summer. The sun's going to go across the sky in a high, long path, whereas the northern hemisphere will have a short, less direct path of the sun. And some parts of the northern hemisphere, notice, are in dark year or all day for weeks. They never even get sunlight like what you'd get in the wintertime in, say, the North Pole regions. Okay, so let's look at this with an animation here. Get out of the laser pointer here, and I've got the animation back here. Oops, that one went away. Well, let's go back. Okay, so this animation shows you the effect of the rotation or the tilt of the Earth and the revolution around the sun. So the motion of the Earth around the sun in 1 year on the seasons. So right now we've got the inclination angle set at 0. That's the tilt of the Earth. Now Earth's tilt is 23.5 degrees. So we're going to put it, let's put it right there at 23. That's our tilt. And we're going to watch it throughout 1 year. You've got the sunlight angle hitting you right here. Notice it's shifting during the year. Right now it's getting higher and higher up. And then also on this view down here, you've got an image of what the sun's path across the sky looks like at that time of year. So, what do you need to pay attention to here? Well, we're in spring right now. Notice the path of the sun. I'll put a marker here on the path of the sun so it keeps it as a little dotted line. There it is in the springtime. Relatively high up. But as we get into summer, notice that path is getting higher and higher. So the last path was higher than the one before it. Now we're getting into summer, it's going to be even higher after we get past the solstice. So in the summertime here, we've got the sun high in the sky. With that high path of the sun, it's going to have a long path across the sky. Long path means the sun is out for a long time period, long days. Think about what it's like in the summer. The sun sets at like 9 o'clock at night, gets up early in the morning. Well, it rises. The sun doesn't really get up. The sun rises early in the morning, and you've got these long sunny days. Once we get into fall, the days get shorter and shorter until we get down to the winter solstice, the shortest day of the year. Why are the days getting shorter? Well, look at the path of the sun. it's getting lower and lower in the sky. Lower path, it's a shorter path. Shorter path means the sun is out above the horizon for a less time period, less warming of the earth. The days are colder. And it's also, notice it's hitting the earth at a more oblique angle, so less density of solar energy per unit area, less heating. So let's speed this up here a bit so you can watch an entire year. I'm going to move it to fast. So first thing to notice here, notice the Earth's angle of rotation does not change. It's always tilted at 23 degrees. It's not wobbling back and forth for the seasons. It stays the same. Also look at the direction of the sun's angles. Here we're going into winter, very low angle, going into summer, high angle hitting us directly, less area taken up by the sun's energy, so more concentrated. Versus in the winter, it's spread out over a bigger area, less direct, not as much warming. That's the first thing to notice. Second part, keep track of that path of the sun. Now in winter, it's very low in the sky. Getting into spring, it's getting higher. Summer, it's high, and then it's starting to drop again later in summer into the fall. Lowest point at the summer or the winter solstice, and then it starts to rise again in the spring. So the sun is at its highest path at the summer solstice, lowest point in the winter solstice, the shortest day of the year. Summer solstice is just the longest day of the year, the longest path is through the sky where the sun is the highest. Okay, so this animation is linked out there on Blackboard. Check that out if you wish to. But key point here, remember, the sun and the earth here, we don't have any change to the angle of Earth's tilt causing the seasons. It's just whether you are tilted toward the sun or away from the sun. And when the southern hemisphere is tilted towards, northern is tilted away, and vice versa in our summer. Hence, Australia's got winter when we've got summer, and when we are in winter, they are in summer, etc. All right, so we can see that path of the sun here. If we go to the winter solstice, the shortest day of the year, where the sun is the lowest path in the sky, here it is, very low in the sky, short path. Contrast that with the summer solstice in June, around the 21st, where it's the longest day of the year. Why long? Well, you've got a long path that the sun takes across the sky because it's up high in the sky. We're tilted towards the sun. So long days with a long path. At the spring and fall equinox, the sun's path is halfway between the winter solstice and the summer solstice. So it's in the middle here, equal day, equal night. And then the summer solstice is the longest day, winter solstice, shortest day. Halfway in between is your equinox. Equal day, equal light.